Okay, welcome back. So we have this starting point. We have this starting point, and we now have this end point. So we know where let me write it again. Started. This is where the rocket or the missile interceptor ended. So let's say we wanted to write this as a function of time. We have these two vectors. What would we do? Well, normally we could use this 1 minus t plus t times the second, or the ending point, and this would work for t from 0 to 1. So when t equals 1 here, when t equals 1, this would be 0, so this would be 0, and t equals 1, this is, so when t equals 1 we're here, when t equals 0, 1 minus 0, t equals 0 here, this goes away, so t equals 0 we're right here where we start, t equals 1 we're right here where we end. Well, that's great, but we're not shooting the rocket in 1 second. And there was also an added piece to the whole project that said that there was a 30-second delay from when the rocket launched to when we were able to detect that it had launched. So what we need to do is adjust this function formula to suit what we need to happen. Okay, so what are some of the things that we know? We know that at the end, time is equal to 117.36 seconds. So there is a 30-second delay from the time that when we know, or from when the rocket launches to the time that we realize it launches. So through some trial and error, we found that to adjust this, we would change t to equal t minus 30 over 87.36. So 87.36 is, whoops, okay, 87.36 is obviously 117.36 minus 30. So let's change that up here. So if we change this 1 minus t to 1 minus t minus 30 over 87.36, and we change this t to t minus 30 over 87.36, what will happen? So at time equal to 30, that's when we shoot off our missile. So here, 1 minus t, if we put 30 here, 30 minus 30 is 0, so 1 minus 0 is 1. So over here, 30 minus 30 is 0, so this would be 0. So we are at 30 seconds, we're at this starting position. This piece drops off. So at 117.36 seconds later, that's when impact happens. 117.36 minus 30 equals 87.36. So 87.36 over 87.36, that's 1. So you have 1 minus 1, which would be 0. And here, like I said before, this would just be 1. So at that time, that's where we end. So this works out. So if we go ahead and multiply this all out, which is long and drawn out, so I'll just write what the final answer would be after it's all worked out. You'd have this new vector function. Looks something like this. 84,480 cosine 53 minus 84,480 cosine 53 times t minus 30 over 87.36 plus 265,135.0297 times t minus 30 87.36. That is the x component, comma, I'm just going to write it down here. Now we're doing the y component, so it'd be 84,480 sine 53 minus 84,480 sine of 53 times t minus 30 over 87.36. That is the y component. And finally the z component be 52,800 times t minus 30 over 87.36. So there it is. That's the function of, or vector function of time with respect to the time of this. So this is for t from 30 to 117.36, and I did this on Maple, so let me pull that up. And there you go. There's where I put in all the code. So if we take a look at this, here's the first the rocket, the original rocket, this first vector equation here, and it's in color red, so that's the original missile that took off. And then if you look through the second one here, you can see how it matches what I just wrote, the 84,480 cosine t minus 30 over 87.36. And this last piece was an adjustment that had to be made because of an issue in Maple. And then here it says the color equals blue, so that's the missile that we're going to shoot. So let's play this so you can see it. So there goes the rocket 30 seconds later, and then it hits. You should change some of the angles. See it again, and then hit. So let's compare this. If we said that it should hit at roughly 265,000 feet along the x-axis, and if we look right here, there's where it hits, and that's 250,000 feet. So that's about right, 265,000 feet. We said that it should hit at 10 miles up, or 52,800 feet. And if you look on the z-axis here, there's 50,000, 60,000, and it hits right around there. And just showing some different views. So there it goes, and there it goes, and there's the hit. Time is 117.36 seconds. And that's it.